Hi everybody, this is another movie on our seasonal orientations, but this one throws in how our seasonal orientations affect how light will hit our gnomons differently on the same part of the earth depending on what time of the year it is. And what this little diagram allows me to do is we have our orbital plane coming right through the center of the earth. We have our parallel lines of light that are also parallel to the orbital plane coming in from the sun. And of course, they're striking at Earth, and I've got some special marks on this globe that you'll see in a minute. This mark here in the middle that right now is running right through the orbital plane is the equator. This is a special one called the Tropic of Cancer, and this is a special one called the Tropic of Capricorn. And all globes have these two lines on them, and we'll see why in a minute. But what this does is this allows me to rotate this because we know in our summertime, for us, our northern hemisphere is tilted more towards the sun, which is over here, than the southern hemisphere. We know that the opposite is true in the wintertime, so I can automatically adjust this to be a wintertime model by making the northern hemisphere point away from the sun and the light coming from the sun. And then on the equinoxes, the hemispheres are equal, so we go right like this. And if you think of these lines of light extending through this, and I'll show you some drawn out examples of this in a moment, you can see that when we are in a summer orientation, the most we tilt towards the sun is right here. And if we had a gnomon, like right here on the Tropic of Capricorn on this day, that gnomon would have the sun directly overhead. This would be a gnomon more like where we live, and you can tell the sun isn't directly overhead on that gnomon, and since this is the most that we tilt towards the sun, we never get a 90-degree altitude where we live. And for us to get a 90-degree altitude where we're at, we'd have to have the Earth tilt this much, and it just doesn't do it that dramatically. It only goes to this point, and that is why all globes make a special mark of the Tropic of Capricorn, because it's the highest you can go on the globe and still get a 90-degree local noon altitude. Conversely, the Tropic of Capricorn is this one in the southern hemisphere, and it is if we put a gnomon in it, it gets a 90-degree altitude, and everywhere south of that will not get a 90-degree local noon altitude ever, because the Earth doesn't tilt that far away. And then finally, right in between those, we get a 90-degree altitude at the equator. And remember, we're in this position twice a year during our spring and our fall equinox. So there's actually 2 days a year where the equator gets this 90-degree local noon altitude. And 1 day a year when it reaches this maximum, we get a 90-degree altitude at the Tropic of Cancer. And one day where we get a 90-degree altitude at the Tropic of Capricorn. Now, I can move this around to show you, and I've just made 3 different diagrams where I've actually drawn the light, and that's what I want to look at next. So I'm going to go ahead and pull those drawings up. My first drawing shows all these light lines extended to these gnomons on our first day of spring or fall. And you can see the equator at this point is not getting any shadow because the sun's directly overhead. But I want you to pay special attention to this one right here, because this would be where we live. And you can see that that is now throwing a shadow off of that gnomon. This is the Tropic of Cancer. It's also throwing a shadow. And this is the Tropic of Capricorn. It's also throwing the shadow. We only have one spot on the Earth on any given day that has a no shadow at what we call local noon, or the middle of the day. So this would be our spring or fall. And again, kind of get a look at that triangle where we live. I am guessing if I was to put an altitude on that, that would be an altitude of right around about 40 to 45 degrees, somewhere in there. Now we're going to move to our summer position. Now I want you to look at the difference in this triangle versus this triangle. All of a sudden the altitude is way greater. That angle right there is probably around almost 70 degrees. Notice that our gnomon at the Tropic of Cancer right here would have the direct sun right on top of it, a 90-degree local noon. Notice now the equator is throwing a shadow, and it wasn't before, but it's because the tilt has changed, which means the light's hitting the Earth differently. And then finally, notice our Tropic of Capricorn is also throwing a shadow. Our next one is going to be of our winter. Now notice the difference. This is the gnomon where we live. That's in our winter. That is maybe about a 20-degree angle right there. Think of the difference between that and what I just showed you for summer. The light is hitting gnomons in our area dramatically different during the winter for us than it is during the summer. And during the winter, the Tropic of Capricorn now is this place on Earth that gets absolutely no shadow at local noon or middle of the day. The equator gets a shadow here, and these shadows get longer as we go towards the globe. And when we're facing away from the sun, they get really long. So once again, there's always a spot on Earth in the middle of the day that's not going to get a shadow. Here on our first day of the equinoxes, either spring or fall, it's the equator that's not getting a shadow. Here, on the first day of our summer, it is the Tropic of Cancer that's not getting a 90-degree, and that's exactly why we mark that specially on a globe. And then finally, on our first day of winter, it's the Tropic of Capricorn that is getting that there's no shadow. The sun is directly overhead. So because the orientation of the Earth changes every day relative to the sun because of this tilt in the Earth, the gnomons that are around the Earth start throwing very, very different shadows. They don't change a lot from one day to the next, but over 3 to 6 months, for winter to spring and fall to summer, they change very, very dramatically. And that, again, is why we have seasons, because of the different way the sunlight hits the Earth. Thanks for watching. That's how light strikes gnomons with seasons.